Hi, this is Victoria Kong at Carroll College, and we have been working on the SHArK project.
We have developed a new way to make the three-element triangle gradient pattern. Though there are many other techniques such as inkjet printing, spray pyrolysis, and the drop method, the technique that we have developed is a screen printing method. It is fast, cost-effective, and generates easily reproducible patterns consistently. In this video, I am going to show you how to make the screen and also how to make the actual film itself. We are going to replicate the results in this paper for the iron, chromium, aluminum triangle pattern gradient.
Open the mixed speedball emulsion and pour a line of emulsion across the top of the mesh. Now take the squeegee and pull the emulsion across the screen. The squeegee should make a zipping sort of noise as it runs across the screen. Make sure to have enough pressure when spreading the emulsion. You want only a thin layer of emulsion on the screen. Now turn the screen over and repeat the process. Only coat the screen once on the front and once on the back. What you should now have is a layer of emulsion lying on the screen. As you pulled the emulsion across the back of the screen, it should have pushed the emulsion out of the other side. As you can see from the shot, the front of the screen has a thicker layer of emulsion than the back does. Find a dark space, such as a drawer, to put the screen in while the emulsion dries. Put the screen face down using something to prop up the frame so that the emulsion does not touch any surfaces. Let the emulsion dry overnight. Take your 100 dpi image over to the overhead projector with the removed Fresnel lens. Set a timer for 5 minutes. Place your screen face down on the image and turn on the overhead light. After exposing the screen for 5 minutes, you should see a faint outline of the triangle gradient pattern in the emulsion. Wash out the screen with cold water. The emulsion exposed to the light should have hardened and will not wash out. The emulsion that was covered up by the ink from the transparency, however, should start to turn gummy and slowly wash out. Lightly run your finger over the emulsion. If needed, use a sponge to gently rub away the unexposed emulsion. Let the emulsion sit out on a hard surface until it is dry. To begin the ink screening process, some prep work must be done. Print out another copy of the ternary gradient pattern and cut out the triangle. Cut out the image along the edges so that you are left with a template of the exact triangle size. Lay the template on a clean substrate. Make sure it is photoconductive side up. Position the triangle so that one tip of the triangle is as close to the edge of one side of the substrate as you can get without actually touching the edge. Trace the triangle onto the substrate with the Sharpie. Repeat this process on a second substrate. After tracing the triangle image, label each of the triangle's corners 1, 2, and 3. And then take your glass scribe pen and label the edge of the substrate with the date. Place your glass substrate labeled 1 on the surface of a lit projector. Place a frame around the image that allows the screen to rest suspended over the glass itself. The mesh should not be touching the glass substrate when placed on the frame. This is called off contact, and is a very important aspect of getting the screen to produce a high quality and accurate print without the ink bleeding. Line up the triangle in the mesh emulsion with the triangle drawn on the glass plate. Having the overhead projector turned on, and thus backlighting the glass and screen, should help with this process. Take the first metal solution that is mixed with the ink base, in this case the iron nitrate ink. Fill a disposable pipette up with the ink. Squirt a line of the ink along the top edge of the triangle, and make sure to dispense enough ink so that the whole triangle image can fill up with the solution. Using the squeegee, pull the ink across the screen, which should fill up each open mesh hole with the metal solution. Do not press down on the mesh. The ink should be viscous enough and the mesh holes small enough that no ink has been deposited onto the glass yet. Push the ink back up to the top of the triangle, taking care to not press down on the mesh. The glass should still be clear of any ink. Once all the ink is back at the top of the triangle, press down on the mesh until you feel contact with the glass plate through the screen, and in one swift motion, pull all the ink across the screen. This technique is called doctor blading the ink. Take off the mesh and look at your glass plate. There should be ink deposited onto the glass plate in a similar pattern to that of the triangle pattern in the mesh. The first filling of the screen with the ink and doctor blading onto the glass substrate usually turns out poorly. This is why you should have 2 glass substrates that have been prepped with the triangle. Without washing out the screen or letting any of the ink run through the screen, place the second glass substrate, labeled number 2, underneath the screen and orient the mesh so that the triangles on the glass plate and in the emulsion line up. Push the ink back up the screen and get ready to doctor blade the ink onto the glass plate. With adequate pressure, doctor blade the ink onto the second glass substrate. Now take your glass substrate number 2 and apply heat. Heat the ink on the plate until the ink no longer contains any water. Doctor blade on another layer of ink and heat until all the liquid has evaporated once more. Carefully remove the screen and the squeegee and rinse both well with the soap solution, deionized water, and finally a squirt of acetone to clear the screen and squeegee of ink. Using the heat gun or the blow dryer, carefully dry the mesh. Be careful, as the heat from the heat gun can sometimes melt the mesh if the screen is placed too close to the heat. Take your first glass plate, labeled number 1, and follow the same steps you did for the first ink solution, but with the second metal solution you are testing, in this case chromium nitrate. Remember to use substrate 1 as your throwaway glass plate, only to be used during the first filling and doctor blading of the screen.